Hello everyone and welcome to today's lesson. Today we are going to learn about trigonometry. That's right, we're going to learn about trigonometry. Woo-hoo! Alright, so we're going to take a look at what we talked about yesterday, special right triangles, how that leads into trigonometry. So we looked at two special cases of right triangles yesterday. We looked at 45, 45, 90 triangles and 30, 60, 90 triangles. And what I'd like you to do is take a look at these two triangles that are given to us. And in a minute, I want you to pause the video, and I want you to fill in everything else you can about these triangles. If you can find angles, find angles. If you can find sides, find sides. So go ahead and pause that and fill in everything you can. Go ahead and pause right now. Did we do that? Did we find everything we could? All right, let's take a look. So in this yellow triangle, we've got a 45, 45, 90 triangle, right? That means that these two legs have to be congruent to each other, doesn't it? So if I've got one leg that's 7, that means the other has to also be 7. That should be pretty clear. And if I know these two legs are 7, and it's a 45, 45, 90 triangle, we saw yesterday that the hypotenuse is always the leg times square root of 2, which means this hypotenuse is going to be 7 radical 2. And over here in this triangle, did you notice that these two sides are half of each other? The hypotenuse is 20 and the shortest leg is 10. Do you remember that from yesterday? That was a 30, 60, 90 triangle. In the 30, 60, 90 triangle, the shortest leg was always half the hypotenuse, right? And if we have a triangle that has that ratio of sides, it means this needs to be a 30, 60, 90 triangle. So this needs to be 30, this needs to be 60. And if I know that, then I know that the middle side was always the shortest leg times square root 3. So this side up here has to be 10 square root 3. So we just found lots and lots of measurements without doing any calculations. No computations, didn't even use Pythagorean theorem. Maybe you used Pythagorean theorem to find this side, I'm not sure. But the fact that we know 30, 60, 90 means we don't have to. And whether you realize it or not, we just did trigonometry. We did a little bit of trig there. We used the fact that we knew these measurements were 45 degrees to know that the ratio of these two sides was 1 to 1, that they are the same measurement. And then I also used that to know that this had to be the short side times square root of 2. That's using trig ratios. And likewise over here, I knew that because the ratio of these sides was a half, I knew this had to be my 30, 60, 90 degree triangle that we saw yesterday. Now, those are two special cases. What we're going to do today with trig is we're going to expand that to all right triangles. Not just these two special cases, but all right triangles. So let's look at trig for a minute. Trigonometry is the study of side ratios in right triangles. So if I've got a right triangle, I can study all the different ways to compare sides to each other. But in order to do that, well, a right triangle, we call the longest side the hypotenuse, right? But then don't we call the short two sides legs? And there's no distinction between these two. For trig, that's not good enough. I need to be able to distinguish the short side from the middle side. Just like in the 30, 60, 90 triangle, remember we had to call the short side A and we had to call the middle side B? That was very important to know those ratios. Same thing happens here. So leg and leg just aren't good enough. So what we do is we establish what's called a reference angle. And I can use either angle A or angle B. It doesn't really matter. The only angle I can't use as a reference angle is C. My 90 degree angle I need to leave on its own. That 90 degree angle is what establishes a right triangle. And now these two angles, I can choose whichever one I want to be my reference angle. I'm going to choose B. That's why I got circled in green here. Now, once I have a reference angle, now I'm going to describe these two legs in reference to that side. So from B's perspective, this leg over here, side AC, this side is across from B. And what I mean by that is, here's B. That side is directly across from it. It's opposite angle B. So we call that side the opposite side, because it's opposite angle B. Just like the hypotenuse is opposite angle C. And angle C is my right angle. The one across from the right angle is always hypotenuse. That never changes. Now our other leg over here is right next to B. Here's B, and our side is right next to it. So we use a fancy word for next to, and that word is adjacent. If you are adjacent to someone, you are sitting next to them. And this side is adjacent to B. Now you may notice that the hypotenuse is also adjacent to B. It's also right next to B. But we already have a name for that one. The longest side is always the hypotenuse already, so the adjacent side is the one that's next to B that's not the hypotenuse. That way we can sort of clarify those. Okay? So now we have three distinct names for each of those sides. Now I can compare those sides using trig ratios. And so we're going to do that right now. So I'm going to move to the next page here, and hopefully this will work. All right, so we've got a triangle. Now we're going to do a case that's not a special right triangle. This isn't a 30, 60, 90. It's not a 45, 45, 90. In this case, A is going to be 51 degrees, B is 39 degrees, and C is our right angle. Okay? Now, I can adjust these to be whatever size I want. I can make this triangle as big or large or small as I want. And what I want to take a look at is some of the ratios here. There are three primary ratios that we're going to take a look at. And those three ratios are the sine ratio. And the sine ratio is the opposite side over the hypotenuse. So angle B is still my reference angle. I'm still going to use that as my reference angle. And from that perspective, the opposite side, whatever that measurement is, divided by the hypotenuse, that ratio is called the sine ratio. And it's S-I-N-E. We abbreviate it S-I-N. Our second ratio is called the cosine ratio. Cosine ratio is the adjacent side divided by the hypotenuse. So again, from B's perspective, this side is the adjacent side. This side is the hypotenuse. The ratio of those two is called the cosine ratio. And we abbreviate that COS. We always use three letters to abbreviate our trig ratios. And our third ratio is the tangent ratio. The tangent ratio is the opposite side over the adjacent side. So from angle B's perspective, it's the opposite side right across from it over the adjacent side. The ratio of those two sides is the tangent ratio. Okay? Now, if we want to calculate that, I've got all the sides measured here, the opposite side, adjacent side, hypotenuse, and here are the measurements right now. What I'd like you to do is I want you to find the sine ratio, find the cosine ratio, find the tangent ratio, and put it as decimals, take it out 2 or 3 places. So try it right now. If you have the right idea, if you have no idea what to do, don't pause it. But if you know what you're doing, pause it, try to find each of those ratios as a decimal. Okay, pause it right now. All right. Hopefully you've done that. And if not, if you have no idea what you're doing, then follow along here. So here are my measurements. My sine ratio is the opposite side over the hypotenuse. So if I want to find the sine of angle B, the sine of 39 degrees in this case, I would do the opposite side, which is 4 centimeters, divided by the hypotenuse, 6.35, and I would divide those. So over here, my sine of 39 is 4 centimeters over 6.35 centimeters, and I get 0.63. And it goes out, I'm rounding to the nearest hundredth here. For the cosine ratio, I would do the adjacent side over the hypotenuse. The adjacent side is 4.93, hypotenuse is 6.35. I divide those two, I get 0.78. And our tangent ratio is the opposite side over the adjacent side. So tangent of 39 degrees would be the opposite side 4 divided by the adjacent side 4.93, and we get 0.81. So those are our ratios for a right triangle with an angle 39. Now here's what's cool. If I change the size of this triangle, make it larger or smaller, these measurements will change. I want you to watch that. But I also want you to watch the ratios. So if I drag this, I make it larger, my sides are changing, but do you notice those ratios aren't? Those ratios are staying constant, no matter how big or small I make this. That's pretty cool. Okay? Now, if I change the angle, then it's going to change the ratio. So instead of 39, I'm going to set this to be 45. So 45, let's see if I can get it as close as I can. There we go. So I set that to be 45. And now my ratios are different, right? My ratios are 0.71, 0.71 for sine and cosine. And my tangent ratio is 45. Now tangent ratio, that should look familiar. Tangent is the opposite side over the adjacent side. If I made this angle 45, doesn't that mean this is a 45, 45, 90 triangle? And doesn't that mean the opposite side and the adjacent side have to be the same? And if I look at that, they're both 4.49, which means when I divide them, I get a tangent ratio of 1. And again, if I change the size of that figure, those ratios stay constant. Okay? Now, 45, 45, 90, 30, 60, 90, those are our special cases, right? All right triangles will always have the same ratios. They will always, the sine of 39 will always be the sine of 39. The sine of 45 will always be 0.71. The cosine of 45 will always be 0.71. And I can find all those values in something called a trig table. Here's our trig table. Table of trigonometric ratios. Here's every angle, at least every whole angle measurement, and every angle's corresponding sine and cosine and tangent. So if I look up 45 degrees, here's 45 degrees. Here is my sine ratio, 0.7071, rounded to the nearest hundredth, 0.71, that's what we have. Our cosine ratio, 0.7071. Our tangent is 1.0, and that's what we have over here. And if I change this back, let's make this, we'll set this back to, what did I have, 39 before? I'll do 34. Let's do 34. If 34 is my reference angle, I'm going to go back to my trig chart, and let's see what we get. 34 degrees has a sine of 0.5592, 0.56. Look at that. 34, my cosine, 0.829, nearest hundredth, 0.83. Perfect. 34 degrees, tangent, 0.6745. There it is, 0.68. Okay? Those are our ratios. Look all right? This lists all sine, cosine, and tangent ratios for every single angle, up to but not including 90, because again, 90 I can't use as my reference angle, but I can use any other angle. Okay? Now this is going to allow us to do a lot of cool things. Are we good so far? Okay. At this point, I'm going to stop this video, and I'm going to start another video with some examples of how we use this stuff. So, I'll see you in a second.